we have done in sequence chapter. So this is less than epsilon already done. This is less than epsilon whenever 0 less equal to mod of x minus c less than delta. Therefore mod of fx is continuous at x is equal to c. A converse is not true. We shall show this by an example. The converse is not true. Converse is not true. We shall show this by giving an example. देखो this is example. Suppose this. Let fx is equal to this thing. It is 1 when x is greater than 0 and minus 1 when x is less equal to 0. Then clearly it is not continuous because right hand limit will be 1 and left hand limit will be minus 1. So fx is not continuous at x is equal to 0, but mod of fx, this will be equal to 1 for every x. If you take mod, then this will become mod x. Mod x value will be equal to 1 for every x belongs to R is continuous at x is equal to 0. Is continuous at x is equal to 0. So with modulus it is continuous, but without modulus it is not continuous. Any problem, Babu? Any problem? Any problem?
No, sir.
Next, देखो heading down. Sequential approach of limits and continuity. Sequential approach of limits and continuity. Sequential approach means using sequence, using concept of sequence, we shall check limits and continuity. Lekho. What is the concept? Look at the board. Dekho, I look at the board. Do not write it. Suppose fx, I do not write. Just look at the board. Suppose fx is a function. We want to check whether limit x tends to, suppose c, fx exist or not. We want to check it. How can I check it? Just we select two sequences. I shall select two sequences xn and yn such that we shall select in such a way that xn tends to c, this limit is c, and yn limit also c. Both xn and yn converge to c. We shall select two sequences in such a way. Now, if f of xn and f of yn converge to different limits, then we shall say that limit does not exist, but if they converge to same limits, suppose this and this converge to same limit, then we can say nothing, no conclusion we can draw from here, because we have chosen only two sequences. There are actually infinite number of sequences converge to C. So this method we shall apply here. Now write it. I write it. Lekho. Let fx be a function. Step 1 lekho. Step 1. Choose two sequences xn and yn. Choose two sequences xn and yn such that xn tends to C and yn tends to C as n tends to infinity. Lekho. If the sequence f of xn and f of yn converge to two different limits, then limit x tends to C fx, does not exist, and if sequence f of xn and f of yn converge to same limits, then limits may or may not exist. We shall use this result. I write a note here. হ্যাঁ বলো।
মে অর মে নট এক্সিস্টের জায়গাটা একটু আরেকবার বলবেন, মানে কেন মে অর মে নটটা বলছেন?
কারণ তুমি তো দুটো নিয়েছো সিকোয়েন্স, আরো তো অনেক সিকোয়েন্স থাকতে পারে, তাদের জন্য তো এক্সিস্ট নাও করতে পারে, তাই না?
আচ্ছা
তুমি তো
ঠিক আছে,
দুটো নিয়েছো, তাই না?
ঠিক আছে।
I write a note here. Note লেখো. When limit does not exist, the function is not continuous. When limit does not exist, the function will be not continuous. So limits and continuity we shall do simultaneously. লেখো.
Sir, repeat for me.
If limit does not exist, then the function is not continuous. क्वेश्चन लेखो so that limit x tends to 5 box of x does not exist I দেখো using this method we shall show all the problems for which limit does not exist wala problem we shall do limit does not exist wala problem but limit exists this is very difficult to check so in this method we shall always check limit does not exist so here our aim is to choose xn and yn solution lekho let fx is equal to box x let fx is equal to box x let us consider two sequences xn and yn we shall choose xn and yn in such a way that xn and yn both tends to 5 both converge to 5 so and one more thing two things are here xn and yn must tend to 5 but f of xn and f of yn will converge to different limits this is our aim so what will be f of xn how can I choose it I bolo to what is value of box 4.9 what is value of box 4.9 it is 4 and box of 5.1 this is equal to 5 so that means this value is 5 just before 5 value is 4 just after 5 value is 5 so just before 4 value is 4 and just before 5 value is 4 just after 5 value is 5 so we shall take two sequences in such a manner so we shall choose two sequences in such a manner that one will be just less than 5 other will be just greater than 5 so let us consider two sequences xn and yn where xn equal to write it where xn is equal to I shall take it is just greater than 5 mane it is 5 plus 1 by n and yn is equal to I shall take just before 5 देखो when n is very large it is just greater than 5 and it is just less than 5 देखो where xn is equal to this and yn equal to this therefore xn tends to 5 as n tends to infinity and yn tends to 5 as n tends to infinity. Now f of xn, f of yn calculate करो. f of xn और f of yn calculate करो. So f of xn is equal to, it is box of 5 plus 1 by n, that is equal to 5 when n is greater than 2, because for n equal to 1 this will become 6. when n is greater than n is greater equal to 2, and f of yn, this will become box of 5 minus 1 by n, which is equal to 4 when n is greater equal to 2. So therefore f of xn, if you take limit, then f of xn converges to 5 as n tends to infinity, and f of yn converges to 4 as n tends to infinity. Lekho. Therefore, the two sequences f of xn and f of yn, the two sequences f of xn and f of yn, and f of yn converge to two different limits, Therefore, limit x tends to 5, box x does not exist. Any problem, Babu? Any problem? হ্যাঁ বলো।
y is greater than equal to 2.
If n is equal to 1, then what is this value বলো তো? For n equal 6, so box of 6 মানে তো 6. That is why I have taken n is greater than equal to 2.
Okay.
I clear? Okay. I write a note here, so I can write here. So therefore, fx is equal to box x is not continuous at x is equal to 5. Is not continuous at x is equal to 5. ঠিক আছে? It is not continuous at x equal to 5. So continuity wala problem mane just you will show that this limit does not exist, then you shall show that you will write this it is not continuous. Question lekho, do it. So that question is this. So that fx is equal to mod of x by x when x is not equal to 0, or it is 0 when x is equal to 0, is not continuous at x equal to 0. And not continuous money, you have to show that limit does not exist. So just I shall show that limit does not exist. Try to do it. I shall give you 2 minutes time. Just I am coming from washroom. 2 minutes. Do it. আমি পরে ফোন করবো, কোনো ঘরে যাচ্ছি একবার, হ্যাঁ পরে ফোন করবো, হ্যাঁ তখনই ফোন করবো।
স্যার
হ্যাঁ বলো।
বলছি আগের নোটটাই আপনি কি বললেন আরেকবার একটু রিপিট করবেন প্লিজ, নোটের মধ্যে।
তুমি এতক্ষণ কাউকে জিজ্ঞেস করতে পারলে না? কাউকে জিজ্ঞেস করলে তো বলে দিত ওরা। কি লিখেছিলাম আগের নোটটায়? লিখলাম তো, তোমরা এতক্ষণ জিজ্ঞাসা করলে না, তুমি বসে আছো। লিখলাম যে ওটা কন্টিনিউয়াস হবে না, লিমিট এক্সিস্ট করে না, তাই কন্টিনিউয়াস হবে না।
আচ্ছা, লিমিট ডাজ নট এক্সিস্ট, সো কন্টিনিউটি ডাজ
নট কন্টিনিউয়াস, সো ইট ইজ নট কন্টিনিউয়াস। এই তো সহজ কথা। এই দেখো, fx is equal to this is not continuous at x equal to 0. We shall, I করেছো তো এটা? Have you done it? Have you done it, anyone? I done it. How can I choose? Here fx is already given, so we do not need to write fx. Let us consider two sequences xn and yn, where xn is equal to, what you have taken xn, how can I take xn? দেখো, mod function is here, and mod function, value of mod function change at x equal to 0. Before 0 mod function is different, and after 0 value is different. What is definition of mod function? This is equal to x when x is greater than 0. It is minus x when x is less than 0. So we shall take xn and yn in such a way that one is less than 0 and other is greater than 0. So we shall take xn is equal to, suppose, 1 by n, or yn is equal to minus 1 by n. Then xn and yn both tends to 0. Then xn tends to 0 as n tends to infinity, and yn tends to 0 as n tends to infinity. Now f of xn or f of yn calculate karo. What are you getting? So f of xn is equal to, f of xn is equal to, it is modulus of xn divided by xn. Modulus of xn মানে it is modulus of 1 upon n by 1 by n, which is a modulus 1 by n is positive, মানে we shall write it as it is 1 by n divided by 1 by n, that is 1, and therefore limit n tends to infinity, f of xn is equal to 1, মানে fxn sequence converge to 1. That means we can write in different way, and f of yn calculate karo. It is mod of yn divided by yn, so it is modulus of minus 1 by n divided by minus 1 by n.
স্যার আগেরটাতে দুটোই মড লিখে দিয়েছিলেন।
ও, এটা মড হবে না। So this will give you, ওটা নিজেরা চেক করে নেবে। So this will be equal to this mod মানে it is positive, it will be 1 by n minus 1 by n, that is minus 1. Therefore limit n tends to infinity, f of yn is equal to minus 1, is equal to minus 1. Therefore the sequences f of xn and f of yn, the sequences f of xn and f of yn converge to two different limits, therefore limit x tends to 0, therefore limit x tends to 0, therefore limit x tends to 0, fx does not exist, and hence fx is not continuous, and hence fx is not continuous, hence fx is not continuous at x is equal to 0. fx is not continuous at x is equal to 0. Next lecture. So that question is this, so that limit x tends to 0 sine 1 by x does not exist sine 1 by x does not exist. Let fx is equal to sine 1 by x. Let us consider two sequences f of xn and yn such that where xn is equal to and yn is equal to. Can you suggest anyone what will be xn or what will be yn? You have to take xn such that xn tends to 0, and another criteria, you have to choose xn in such a way that you can easily find value of sine 1 by x. You have to find value of sine 1 by xn. What will be xn? I shall take it as 1 by twice n pi, and this is 1 by 2n pi plus pi by 2. Then xn tends to 0. n is infinity mane 1 upon infinity, so xn tends to 0 as n tends to infinity, and yn tends to 0 as n tends to infinity. Now f of xn calculate karo. f of xn is equal to, it is sine 2n pi. Sine 2n pi mane value is 0, and f of yn is equal to sine 2n pi plus pi by 2, that is equal to 1. So therefore f of xn converges to 0 as n tends to infinity, and f of yn converge to 1 as n tends to infinity. Therefore, the sequences f of xn, therefore the sequences f of xn and f of yn converge to two different limits, therefore limit x tends to 0, sine 1 by x does not exist. I note lekho, write a note here. You can write a note. So since it is not since limit does not exist, so can you say that it is continuous? Is it continuous?
No.
No. So write a note here. Since limit does not exist, therefore fx is equal to, I shall write this function, fx is equal to sine 1 by x when x not equal to 0 and 0 when x equal to 0 is not continuous at x is equal to 0. Now I shall give you 3 homeworks. এই দেখো, very simple homework. আচ্ছা, can you say that? আচ্ছা বলো তো, if it is cos 1 by x, then what will you do, babu? Cos 1 by x. Then also we shall do same thing, same xn, same yn. Just you will do same thing. I clear what I want to say? Oh, acha bolo, next one more thing. Acha, if you take, so cos 1 by x wala homework, just tell me, if I take fx is equal to sine 1 by x square, I write this as homework, write it. So that limit x tends to 0, sine 1 by x square does not exist.
স্যার আরেকবার বলবেন?
So that this, that's it. এই যে এটা লেখা আছে। হ্যালো,
আচ্ছা ঠিক আছে।
আমি বাইরে আমি পড়াচ্ছি, পরে ফোন করছি। কেন তুই বলবি নাকি? আচ্ছা, ঠিক আছে, আমি পরে ফোন করছি। Hey, bolo. So what will be your xn and yn? Can you tell me? What will be xn and yn? Since here it is 1 by x square, we shall take xn equal to root of this, and then same thing. Clear, Babu? Is it right? Clear? So if it is cos 1 by x square, then also you will take same thing. So write this as homework. The limit x tends to 0. Limit x tends to 0. Sin 1 by x square does not exist. Does not exist. This is your homework. You will do this. And same thing for cos 1 by x square also. Cos 1 by x square also. Next level. So you will do this thing. Another homework lecho. Another homework lecho. So that limit x tends to 0, 1 divided by 2 plus e to the power 1 by x, 2 plus e to the power 1 by x does not exist. This does not exist. We shall show that this does not exist. This is your homework and you will think it. You will do it. You will do it. Next lecho. Cauchy's general principle of convergence. Cauchy's general principle of convergence. Cauchy's general principle of convergence. A statement lecho. The necessary and sufficient condition. The necessary and sufficient condition that a function fx may tend to a definite limit, as x tends to a, is that for any epsilon greater than 0, there exists a delta greater than 0 such that mod of fx1 minus f of x2 is less than epsilon for every pair x1 y1, for every pair x1 and y1, x1 x2 of values of x satisfying 0 less than mod of x minus x1 is less than delta. x1 minus a x1 minus a is less than delta and modulus of x2 minus a is less than delta. So this is Cauchy's criterion. I look at the board again. We want to check whether this limit exists or not. That is the question. How can I check the existence? We shall take x1 and x2 which are very close to a. And this means x1 is very close to a, x2 is very close to a, very close to a. And for this x1 and x2, f of x1 and f of x2 will be very close to each other. F of x1 and f of x2 will be very close to each other. So f of x1 minus f of x2 is less than epsilon means x1 x2 very close. In this method also, it is easy to check limit does not exist. How can I check whether limit does not exist? So we shall take two values x1, x2 very close to a, and we shall show that the f of x1 and f of x2 are not close to each other. Then we shall say that limit does not exist. But limit exists, it is very difficult. It is very difficult. I lekho, question lekho, question lekho. Using Cauchy's criterion, so that limit x tends to 0, cos 1 by x does not exist. So using Cauchy's criterion, we shall show that this limit does not exist. We have already done this by sequential approach method. Now we are going to discuss another method. Lekho, how can I check it? Lekho, let fx is equal to cos 1 by x. Let fx is equal to cos 1 by x. Now fx equal to cos 1 by x. Now we shall choose x1 and x2 two numbers, x1 and x2 two numbers which are very close to 0. Which are very close to 0. I lekho. Let epsilon greater than 0 be any number. Let epsilon greater than 0 be any number. Let x1 is equal to, I shall take x1 in this way. Same thing we shall follow which I have done in sequential approach. So I shall take x1 is equal to 1 by 2n pi. Here you have to mention n is integer, n is natural number. In sequential approach, we have not mentioned n is natural number because by default it was natural number sequence, na? But here you have to mention n is natural number. And x2 is equal to, we shall take 1 by, this is 2n pi plus pi by 2 suppose. Here also n is natural number. Lekho. For for sufficiently large n, for sufficiently large n, x1 and x2 are very close to 0, x1 and x2 are very close to 0, very close to 0. লেখো f of x, modulus of fx1 minus f of x2, this is equal to, if this is mod of cos 2n pi minus, it is cos of, this is 2n pi plus pi by 2, pi by 2, that is equal to modulus of cos 2n pi মানে it is cos 0, that is 1, আর cos pi by 2 মানে it is 0, so this is 1. We cannot say that this is less than epsilon, since epsilon greater than 0 is arbitrary. Epsilon is greater than 0 is arbitrary. মানে you can choose any value of epsilon. দেখো, if you choose epsilon is equal to 0.5, then we cannot say that 1 is less than 0.5. তাই লেখো, লেখো, লেখো। Therefore, by Cauchy's general principle of convergence, therefore by Cauchy's principle of convergence, limit does not exist, limit does not exist write a homework, you will do, write a homework, write a homework, লেখো, so that limit x tends to 0, sin 1 by x does not exist, sin 1 by x does not exist, we shall show that sin of limit x tends to 0, sin 1 by x does not exist. Is it possible to do? Same functions, same x1 and x2 you will consider. Same x1 and x2 you will consider. Next lecho, this type of problem, so that limit x tends to infinity, sin x does not exist, does not exist. This is the problem where x tends to infinity, x tends to infinity. So here we shall choose, x1 and x2 which are very large, which are very large. লেখো, লেখো, let x1, let fx equal to, first let fx is equal to sin x, let fx is equal to sin x, let fx is equal to sin x, and epsilon greater than 0 be any number, let epsilon greater than 0 be any number, let x1 is equal to 2n pi and x2 is equal to, this is 2n pi plus pi by 2, where n belonging to natural number set. Lekho. So when n tends to infinity, x1 tends to infinity and x2 also tends to infinity. That means this means actually for very large positive integer, large natural number, x1 and x2 are also very large. x1 and x2 are also very large. Now f of x1, f of x2 calculate karo. f of x1 is equal to, it is sine 2n pi, that is equal to 0. And f of x2 is equal to, it is sine 2n pi plus pi by 2, that is equal to 1. Therefore, mod of fx1 minus f of x2, this will become 1, which is not less than epsilon. Since epsilon greater than 0 is arbitrary, since epsilon greater than 0 is arbitrary, therefore, limit x tends to infinity, sin x does not exist. Therefore, limit x tends to infinity, sin x does not exist. I clear, Babu? I clear? I clear? Any problem? Any problem? Lekho. I question lekho. Am I audible? Hello? Am I audible, Babu?
Yes.
So, I question lekho. Question is this: let f from R to R, let f from R to R be a function which satisfy the condition mod of fx1 minus f of x2 is less equal to x1 minus x2 whole square, then so that fx is continuous on R. fx is continuous on R. We shall show that fx is continuous on R. How can I show this? I lekho. Solution lekho. Modulus of solution lekho. Write it. Modulus of fx1, this start from here. Modulus of fx1 minus f of x2 is less equal to x1 minus x2 whole square. This implies minus of x1 minus x2 whole square is less equal to f of x1 minus f of x2 less equal to x1 minus x2 whole square, we can write a modulus x is less equal to 5. What does it mean? X is less equal to 5, greater equal to minus 5. We can write it in this way. Now we shall take, if we take h is equal to x1 minus x2, then what are you getting? This is minus h square less equal to f of x1 minus f of x2 less equal to h square, where h is equal to x1 minus x2. We can write it as divide by 1h. So this is f of x1 minus f of x2 divided by h less equal to h. Now, we can put x1 is equal to x2 plus h. From here x1 is equal to x2 plus h. So we can write it as minus h less equal to f of x2 plus h minus f of x2 divided by h less equal to h less equal to h. Now we have done in class 11-12. We have done in class 11-12 this thing. What was definition of f dash t? F dash t means limit h tends to 0. F of a plus h minus f of a divided by h. This was definition of f dash a. We have done in class 11-12. And also we know if a function is differentiable, then it is continuous. But if a function is continuous, then it may or may not be differentiable. It may or may not be differentiable. So we shall use it. We shall use it. Now we shall take limit and we shall use here sandwich theorem. Since limit h tends to 0, minus of h is equal to 0, and limit h tends to 0, this h is equal to 0. Therefore, limit h tends to 0, f of x2 plus h minus f of x2 divided by h is equal to 0. So this means this is by this definition it is f dashed x2 is equal to 0. So that is fx is differentiable at x2. That is fx is differentiable at x2. Since x2 is any real number, therefore fx is continuous at x2. fx is continuous at x2. Sorry. Since what you have written? What you have written, Babu?
Sin x is any real number, so fx is continuous at x2.
fx is continuous on R. Since x2 is any real number, therefore fx is continuous on R. Next লেখো some properties of continuous function, heading down. Properties of continuous function. We shall discuss some properties of continuous function. Continuous function মানে we can draw the graph continuously. Suppose this is A point, this is B point. A function is continuous মানে we can draw its graph continuously from A to B. Or this may be, this point is A, this point is B. Suppose f of A is this or f of B is this. Function is this type. This is a continuous function. So we shall write some properties. Number one lekho. First property is this. Number one lekho. If a function fx is continuous, if a function fx is continuous on closed interval AB, then it is bounded there.
স্যার একবার রিপিট করবেন?
If a function fx is continuous on closed interval AB, then it is bounded there. এই দেখো bounded মানে every value of the function lies between two boundaries. দেখো, if we consider this continuous function, then this is the lowest value, this is the highest value. So, or in other word, we can say that the fx will have maximum and minimum value if it is continuous. So continuous money, it will have maximum value or supremum, and it will have minimum value or infimum. So second property we shall write here. Second property lekho. If fx is continuous, if fx is continuous on closed interval AB, then there exist 2 points C and D. Then there exist 2 points C and D in closed interval AB, where if attains its supremum and infimum. Supremum money maximum value, infimum money minimum value. Next lecture. Number three. This is known as Bolzano's theorem. Bolzano's theorem. We have done this in theory of equation, but we have not mentioned the name at that time. Write it. Bolzano's theorem. Lekho. If f from A to B, if f from A to B to R be a continuous function, be a continuous function, be a continuous function, and f of A and f of A into f of B less than 0, then there exists at least one point C in open interval AB such that f of C is equal to 0. F of C is equal to 0. We have already done this theorem. This result we have already used in theory of equation. I look at the board. We have done this theorem. If f of A and f of B are of opposite sign, then there will be a root between A and B. We have done it. So this was Bolzano's theorem. If f of A and f of B are opposite sign, suppose it is A and this is B, f of A and this is B, f of B opposite sign, then obviously there will be a point C where f of C is equal to 0. At this point, value of the function is 0. Value of the function is 0. We shall use it. Question lekho. Prove that. Question is this. Prove that there exists C in open interval 0 to pi by 2 such that C is equal to cos of C. C is equal to cos of C. So here we shall use Bolzano's theorem. From this part I shall choose a function. Let fx is equal to x minus cos x in, you have written function mane you have to mention the domain. देखो C is in open interval. Look at the theorem. C is in open interval, but function will be in closed interval. So I have taken function in closed interval, but C will be in open interval. So first we shall discuss the continuity of fx, and then we shall show that f of 0 and f of pi by 2 are of opposite sign. Lekho. Since x and cos x both are continuous on closed interval 0 to pi by 2, therefore fx is continuous on closed interval 0 to pi by 2. fx is continuous on closed interval 0 to pi by 2, fx is continuous on closed interval 0 to pi by 2. Now f of 0 calculate karo. F of 0 mane it is this will be -1, and f of pi by 2 it is pi by 2 minus cos pi by 2 mane 0. So it is less than 0. This is greater than 0. Therefore f of 0 into f of pi by 2 is less than 0. Therefore, there exists C in open interval 0 to pi by 2 such that f of C is equal to 0, which implies f of C mane from here we get C minus cos of C is equal to 0. That means C is equal to cos of C. C is equal to cos of C. I clear, Babu? I clear? I clear? Any problem? হ্যালো, শুনতে পাচ্ছ তোমরা না? হ্যালো,
ইয়েস স্যার।
রেসপন্স করো। সবাই ঘুমিয়ে পড়লে নাকি? লেখো, আর একটু করে নাও, আর একটা দুটো অঙ্ক করে নাও, হয়ে গেছে, করো, লেখো। কোশ্চেন লেখো, কোশ্চেন লেখো। If f from this function question is this: if from a to b to a to b, so this is a function, its domain is the closed interval ab and its codomain is closed interval ab, be a continuous function. If this be a continuous function, be a continuous function, then there exists a point C, in closed interval AB such that f of C is equal to C. Here f is continuous function in closed interval AB and a range of the function is AB. It is given, here it is given that x is from A to B and fx is also lies between A and B. We shall show that f of C is equal to C. Here C is in closed interval AB, but in Bolzano's theorem C was in open interval AB. So C belongs to closed interval AB mane either C is equal to A or value of C may be equal to B or C lies between A and B. So here we shall consider three cases. When C is equal to A, we shall show that this may hold. When C equal to B, this may hold. and when C lies between A, B, this may hold. So we shall consider three cases. লেখো দেখো here x is from a, x lies between A and B or fx lies between A and B. So if fx equal to A, so we can write in this way. If fx is sorry. देखो if f of A is equal to A, if f of A is equal to A, suppose at x is equal to A point, value of the function is A. So if f of A is equal to A, then value of C will become A, then C is equal to A. And if f of B is equal to B, suppose at B point value of the function is B. At B point value of the function is B. So if f of B is equal to B, then here C is equal to B. Now we shall consider the case when f of A not equal to A and f of B not equal to B, then what will happen? If f of A not equal to A and f of B not equal to B, then what will happen? We shall show that there is a C between A and B. We shall show this. Lekho. We shall consider a function. Let f of x is equal to this function. It is f of x minus x. F of x minus x. Let f of x is equal to fx minus x. Now, fx is continuous, it is given. Since fx and x both are continuous, therefore capital Fx is continuous on closed interval AB. That is, capital Fx is continuous on closed interval AB. On closed interval AB. Now write. What is value of A? I look at the board again. Now f of A is equal to, it is f of A minus A. And f of B is equal to, it is f of B minus B. We have written here, the f of A is not equal to A. That means f of we have written the every value of fx, every value of the function. I look at the board. Every value of function lies between A and B. So f of A must lie between A and B, and f of B also must lie between A and B. But here I have taken f of A is not equal to A. So f of A is not equal to A. What does it mean? The fa is greater than A. So fa greater than A means it will be positive, greater than 0. And by same logic, f of B is not equal to B. So f of B will be not equal to B means it is less than B. So f of B is less than B means it is negative. Is it clear? Devpriya, is it clear?
Yes, sir.
Yes. Now, So this means f of a into f of b, লেখো f of a into f of b is less than 0. Therefore, by Bolzano's theorem, by Bolzano's theorem, there exists C in open interval AB such that capital F of C is equal to 0, which implies capital FC mane, capital F of C mane fx function is this, whereas fx is this. Capital F of C mane it is f of C minus C is equal to 0. That is f of C is equal to C. Lekho. Therefore, considering all the cases we get, therefore considering all the cases we get, therefore from all the cases we get, what are you getting? There exists, write this, there exists a point C where C belongs to closed interval AB.
Sorry, I will.
Therefore, there exists a point C in closed interval AB such that f of C is equal to C. F of C is equal to C. ঠিক আছে, keep till today here. Next day just I shall do one theorem. This is slightly different and difficult. So we shall start from intermediate value theorem. I মনে করে দেবে এটা IPT, intermediate value theorem we shall start, and then we shall go to integral calculus. It will take 30 minutes, and then we shall do integral calculus. তোমাদের পরীক্ষা কবে শুরু বলতে পারো? 24 নভেম্বর। পরীক্ষা, ম্যাথস পরীক্ষা কবে?
11 ডিসেম্বর।
11 ডিসেম্বর। তার আগে কোনো ছুটি আছে নাকি?
হ্যাঁ,
ম্যাথসের আগে ছুটি আছে?
ম্যাথসের আগে 5 days হলিডে আছে আমাদের কেমিস্ট্রিতে।
আচ্ছা শোনো, তোমাদের আমরা তাহলে এই কামিং উইকে আমরা দুটো ক্লাস করে নেব, 2 days. We shall take 2 classes in this week, coming week. One is on Thursday or Friday and Saturday we shall do class in this week. In this week we shall do 2 classes, Friday and Saturday. বলে রাখলাম সবাইকে, ঠিক আছে? কোনো শিডিউল রাখবে না। Friday this may be from Friday this will be from 6 to 8, 6 p.m. to 8 p.m. and Saturday also we shall do Saturday.
সকালে করলে ভালো হতো না দুদিন?
সকালে করলে ভালো হয়।
হ্যাঁ,
আচ্ছা তাহলে ফ্রাইডে এক কাজ করো, তা ফ্রাইডে ফ্রম 10 to 12 করে দাও। 10 to 12 we shall do 2 days from 10 to 12. We shall do integral calculus, it will be completed. We shall do 10 to 12 class, okay? Friday and Saturday. Okay. Thank you very much. So keep it here. Thank you very much. Thank you all.
থ্যাংক ইউ।
You can leave now.
সাকসেসিভ ডেরিভেশন বাকি ছিল রাইট।
তোমাদের তোমাদের ফ্রাইডে ব্যাচে একটু বাকি ছিল, তাই না? তাহলে তোমাদের ফ্রাইডে আমি অন্যদিন একটা ক্লাস নিয়ে নেব, ঠিক আছে? আমি জানিয়ে দেবো তোমাদের এই দুটো ক্লাস পর, আর একটা অন্যদিন আমি ক্লাস নিয়ে নেবো এদের মাঝে, ঠিক আছে? ঠিক আছে, রাখ, ইউ ক্যান লিভ নাও।
রুদ্র ভাত খেয়েছো হ্যাঁ
infinite discontinuity at x is equal to a, where fx has infinite discontinuity at x is equal to a. So that for example, suppose 1 to 5, 1 by x minus 1 dx, this integration, here it is fx, at x equal to 1, this will be undefined or infinite discontinuity. So we want to integrate from 1 to 5, but at x equal to 1, there is infinite discontinuity. That is why I shall integrate from 1 plus epsilon to 5. Epsilon is this distance. This distance is epsilon. Now when epsilon tending to 0, now if I take epsilon tending to 0, then the total region 1 to 5 will be covered. So I can write it. So in this problem, infinite discontinuity at A, so A to B is the limit. I shall integrate from A to A plus epsilon to B, and then we shall make epsilon tending to 0, then ultimately total region will be covered. So we can write it. Lekho, therefore, integration A to B, next line lekho. Therefore, A to B fx dx is equal to this is, we shall integrate from A plus epsilon to B fx dx, and then we shall take limit epsilon tending to 0 plus, limit epsilon tending to 0 plus. Any problem, Babu? Any problem? Srinita, any problem?
No, sir.
Oh. Next lekho. Number 2, second is this. Number 2, integration from A to B fx dx, where fx has infinite discontinuity at x is equal to b, at x equal to b. So we want to integrate from A to B, but it has infinite discontinuity at x is equal to b. So we shall integrate from A to b minus epsilon. This length is epsilon, and then we shall make epsilon tending to 0. Then this total region will be covered. So this is equal to, write it. So integration A to B fx dx is equal to, this is equal to, we shall write it in this way. It is integration from A to b minus epsilon fx dx, here limit epsilon tending to 0 plus. Type 3. Type 3. Type 3. integration from a to b, integration from a to b fx dx, integration from a to b fx dx, where fx has infinite discontinuity at x is equal to c, at x equal to c, x equal to c, where a less than c less than b, where a less than c less than b. And that means suppose a is this, b is this, c is this point. It has infinite discontinuity at x equal to c. So we shall integrate from a to c minus delta and then c plus epsilon to b. This length is delta and this length is epsilon. This length is epsilon. So a to c minus delta and c plus epsilon to b we shall integrate. Here epsilon and delta may be different, but if epsilon is equal to delta, then this integration has some special value. It has some special name. We shall write here. Lekho. So integration a to b fx dx is equal to it is integration from a to c minus delta f dx, limit delta tending to 0 plus b f dx, limit epsilon tending to 0 plus. Lekho. If epsilon is equal to delta, if epsilon is equal to delta, if epsilon is equal to delta, then the integration is, then the value of integration is said to have Cauchy's principal value, is said to have Cauchy's principal value, Cauchy's principal value. I question lekho. Acha, first write this. I note lekho. If value of improper integral, write a note here. If value of improper integral exists finitely, if value of improper integral exists finitely, then the integral is said to be convergent. Then the integral is said to be convergent. So convergent means this integration will have finite value. If the integration has no finite value, Suppose this integration is infinity, then we shall say that the improper integral diverges to plus infinity. If the value is minus infinity, then we shall say that it diverges to minus infinity in this way. A question lekho. Check the convergence of the following improper integrals. Check the convergence of the following improper integrals. Number one, I shall write one by one question and solve one by one. Number one, integration 0 to infinity dx divided by x plus 1 into x plus 2, this. I देखो, it is type 1 improper integral. So I shall first integrate from 0 to x plus 1 into x plus 2, and then we shall take limit capital X tends to infinity. So limit x tends to infinity. This is integration from 0 to x. I shall use integration by partial fraction. It is x plus 1 minus x plus 2, this dx. This is equal to limit x tends to infinity. This is log of x plus 1 minus log of x plus 2, integration from 0 to x, that is equal to limit x tends to infinity. It is actually log of x plus 1 by x plus 2, integration from 0 to x, So this is equal to limit x tends to infinity. This will become log of capital X plus 1, capital X plus 2 minus 0 mane it is log of half. It is a constant. We shall find this limit. So limit capital X tends to infinity. I can write it as I divide by x. So 1 plus 1 by x. It is 1 plus 2 by x. You can write it as plus log of 2. Now x tends to infinity mane 1 by x is 0, 2 by x is 0. So it is log 1, which is again 0. So finally we are getting log of 2, which is finite value, Therefore, the improper integral is convergent. I clear, Babu? I clear? Any problem?
No, sir.
नो प्रॉब्लम. नेक्स्ट लिखो. नेक्स्ट लिखो. क्वेश्चन लिखो. इंटीग्रेशन 2 to infinity. Integration 2 to infinity. This is dx divided by x into log x. Dx divided by x into log x. I try koro. What are you getting? Try to do it. I do it, please. Well, what are you getting? So we can write it as this thing. It is integration from 2 to capital X dx divided by x into log x and limit x tends to infinity. So this is equal to, I shall take log of x is equal to z. Therefore 1 by x dx is equal to dz. So dx by x is equal to dz. Limit x tends to infinity. Integration, it is dz by z. When x is equal to 2, z is equal to log of 2, and this will give you log x. That is, limit capital X tends to infinity. dz by z means it is log of z. Limit of integration is from log 2 to log x. This is equal to limit capital X tends to infinity. This is log of, it is log x minus log of, this will be log of 2. Log of 2. Now, when x is infinity, when x is infinity, log infinity is infinity, and again log infinity means infinity. So infinity minus some finite value, this will be infinity. This will be infinity. Therefore, therefore, the given improper integral, therefore the given improper integral is divergent and diverge to plus infinity. Diverge to plus infinity. Sivayan, any problem? Sivayan?
Ask yourself, chart.
Oh. देखो. Next देखो. Integration from 0 to 3. Integration from 0 to 3. dx divided by root under 9 minus x square. 9 minus x square. देखो, this is type 2 improper integral. Solution लिखो. Let fx is equal to 1 by root of 9 minus x square. I follow at which point it has infinite discontinuity. At x is equal to 3. So fx has infinite discontinuity at x is equal to 3. Yusuf, is it clear? Yusuf, is it clear?
Yes, sir.
Yes, okay. So this integration, therefore, integration from 0 to 3, this fx dx is equal to, it is integration from 0 to 3 dx divided by root under 9 minus x square, and here limit epsilon tending to, this is 3 minus epsilon tending to 0 plus. At x equal to 3, it has infinite discontinuity, so we shall integrate from 0 to 3 minus epsilon. This is limit epsilon tending to 0 plus. This will give you, what are you getting? What is the value of integration? What is this value of integration? Find karo bolo. What is this integration? Is sine inverse, তাই না? This equal to, this is sine inverse x by a মানে 3. Limit of integration is 0 to 3 minus epsilon. So limit epsilon tending to 0 plus. It is sine inverse 3 minus epsilon by 3. Or 0 put karo, this will become sine inverse 0. That is 0. That is 0. So this will give you epsilon is equal to 0 put karo, then ultimately it is sine inverse 1. That is pi by 2. Lekho. Which is finite value, therefore the given improper integral is convergent. Therefore the given improper integral is convergent. Next lekho. Question is this. Lekho. So that question is this. So that integration 0 to infinity e to the power minus px dx converge মানে down arrow, converge for p greater than 0 and diverge for p less equal to 0. We shall show this. Lekho. So here for p less than 0 it is convergent, we shall show, and for p less equal to 0 it is divergent, we shall show this. Lekho. When p is not equal to 0, separately find for p is equal to 0. Lekho. When p is equal to 0, integration 0 to infinity e to the power minus px dx, p is equal to 0 মানে it will be integration 0 to infinity this dx, which is equal to limit capital X tends to infinity integration from 0 to capital X this dx. So this is limit capital X tends to infinity. This integration will be x. Limit is from 0 to x. This is limit capital X tends to infinity. That is capital X, which is infinity. So that means, that is the improper integral is divergent for p is equal to 0. So for p is equal to 0, it is divergent, we have proved. Now consider the case when p not equal to 0. P not equal to 0. Next lekho. When p not equal to 0. When p not equal to 0. What are you getting? When p not equal to 0. So this is equal to limit capital X tends to infinity, integration from 0 to capital X, e to the power minus px dx. So this is equal to limit capital X tends to infinity. This integration is e to the power minus px divided by minus p. Integration is from 0 to capital X. This is equal to limit capital X tends to infinity. If I put x is equal to capital X, we are getting e to the power minus p into x divided by minus p minus of 0 mane this will become 1. So finally it is 1 by p. So you can write it in this way. Limit capital X tends to infinity, 1 by p minus e to the power minus px divided by p. Now here the limit will vary when p is positive and when p is negative. Or you can do in this way. You can take this p common. I think it will be better. Take 1 by p common. So it is 1 by p common, and this will become then 1 by e to the power px. It will be better for you to understand this. Now when p is positive, when p is positive, what are you getting? When p is positive, what are you getting? When p is greater than 0, when p is greater than 0, what are you getting? When p is greater than 0, p positive mane, suppose p is equal to 2. So if p is equal to 2, then it is 1 by e to the power 2x. 1 by e to the power 2x. So 2x e to the power 2x will be infinity. So 1 by infinity mane this will become 0. This will become 0. So this part will become 0. Then this value will be equal to only p. So this will be equal to only p when p is greater than 0 and if p is negative, suppose p is equal to -2, p is equal to -2, then this value is 1 minus e to the power, actually this is -2 মানে it is 2x. So x tends to infinity মানে I have written this, I have written this will be capital X, this will be capital X. So this is capital X. So when x is infinity, this part will be infinity. So 1 minus infinity mane result will be minus infinity. Result will be minus infinity. So minus infinity mane it is divergent. So it is divergent. Clear, Babu? Any question here? Any question? Any problem? Sudipto, any problem? হ্যাঁ বলো।
স্যার p is নেগেটিভ, ওটা আরেকবার বোঝাবেন?
হ্যাঁ বলো, কেন, কোথায় বলো, অসুবিধা কোথায় বলো।
স্যার মানে ওটা ডাইভারজেন্ট কি করে হচ্ছে ওটাই বুঝতে পারলাম।
হ্যাঁ এটা p তো নেগেটিভ,
হ্যাঁ স্যার।
p নেগেটিভ, সো p নেগেটিভ মানে it is e to the power, this is 2x, তাই না?
হ্যাঁ
তো e to the power 2x. So x tends to infinity মানে it is e to the power,
ওটাই ইনফিনিটি হয়ে যাচ্ছে।
ইনফিনিটি। এই সুদীপ্ত ঠিক আছে? সুদীপ্ত ঠিক আছে? হ্যালো সুদীপ্ত, শুনতে পাচ্ছ? সুদীপ্ত জয়েন করলে না? দেখো, so finally what are you getting there finally? So for p greater than 0 it is convergent and for p less equal to 0 divergent. Any question? Sonak, any question?
No, sir.
Onis, any question?
নো স্যার।
Sibayan, any problem?
No, sir.
Priyanjita, any problem?
No, sir.
Very good. Next lekho. So this is actually very important result we shall use later. This is very important result also we shall use later. Next lekho. Next question. This is number 1. And next is this. So that integration a to infinity, this a is greater than 0, integration from a to infinity, dx divided by x to the power mu converge for mu greater than 1 and diverge for mu less equal to 1. It will converge for mu greater than 1 and diverge for mu less than 1. দেখো, we shall show this. First, for mu is equal to 1 test karo. লেখো, when mu is equal to 1, when mu is equal to 1, when mu is equal to 1, integration a to infinity dx divided by x to the power mu is equal to, this will become a to infinity dx by x. This is type 1 improper integral, so it is limit capital X tends to infinity a to capital X dx by x. That is limit capital X tends to infinity. This will become log x integration from a to capital X. This is equal to limit capital X tends to infinity. It is log of capital X minus log of a. When x is infinity, this log infinity will become infinity. So this will be infinite. So this is equal to infinity. This is equal to infinity. That is the integral is divergent. That is, the integral is divergent. So we have proved when mu is equal to 1, it is divergent. It is divergent. Now, for mu is equal to 1, it is divergent. Now, when mu is not equal to 1, when mu is not equal to 1, what are we getting? When mu not equal to 1, this is equal to limit capital X tends to infinity a to capital X dx divided by x to the power mu dx divided by x to the power mu. This is equal to limit capital X tends to infinity. This will give you, this integration is x to the power minus mu plus 1 divided by minus of mu plus 1. Integration is from a to capital X. A to capital X. So this is equal to, I can take here, this is limit capital X tends to infinity. This will give you, if I put x, so x to the power 1 minus mu divided by 1 minus mu minus a to the power 1 minus mu divided by 1 minus mu. So if I take, this is equal to, here we will get limit when mu is greater than 1. What are you getting? Mu is greater than 1 mane, mu is greater than 1 mane, look at the board. For example, suppose mu is equal to 3. So then x to the power 1 minus 3 divided by this will become minus 2 minus a to the power minus 2 divided by minus 2. So this will give you x to the power minus 2. X to the power minus 2 money, this is actually 1 by x square. Now x tends to infinity money, this part will become 0. This part will become 0. So we will get only this part. So mu greater than 1 money, this part will become 0. So only we will get this part. It is minus of a to the power 1 minus mu by 1 minus mu. And when mu is less than 1, again look at the board. Suppose mu is equal to minus 3, then we are getting x to the power 4 divided by this will become 4 minus a to the power 4 divided by 4. So what are we getting? This will give you x is infinity, mane this part will become infinity. So this will become infinity. So final conclusion is this. Therefore, write it. Therefore, integration from a to infinity dx divided by x to the power mu converge for mu greater than 1 and diverge for mu less than equal to 1, and diverge for mu less than equal to 1. Any problem, students? Any problem?
No, sir.
No. Very good. Next result. Next lekho. These are important results, Babu. These are also important results. We shall use it. Lekho. Next lekho. Next question lekho. So that integration a to b dx divided by x minus a whole to the power mu converge for mu less than 1 and diverge for mu greater equal to 1. And which type of improper integral is it? Which type of improper integral is it? Type 1 or 2?
2.
At which point infinite discontinuity is there?
Equal to a.
At x equal to a. Lekho. Solution lekho. First, at mu is equal to 1 test karo. Lekho. When mu is equal to 1, integration a to b dx divided by x minus a dx divided by x minus a to the power mu mane write it to the power mu. This is equal to integration a to b dx divided by x minus a. So this will give you, since it has infinite discontinuity at x equal to a, so this is a, this is b, so we shall integrate from a plus epsilon to b, so it is a plus epsilon to b. This is dx divided by x minus a, and limit epsilon tending to 0 plus. This will give you it is limit epsilon tending to 0 plus, this will become log of x minus a. This limit will be from a plus epsilon to b. So that is equal to what are you getting? It is limit epsilon tending to 0 plus, this will be log of, it is mod of b minus a minus, this will be log of epsilon. देखो, when epsilon is very close to 0, this will become minus infinity. This will become minus infinity. So ultimately this will become minus infinity, or here minus sign. So minus of minus infinity, this will give you actually plus infinity. So this will give you plus infinity plus something. So it is infinity. It is infinity. So lekho. So this is equal to infinite. That is, the improper integral is divergent. That is, the improper integral is divergent. Next lekho. When mu is not equal to 1, what are you getting? When mu is not equal to 1, what are we getting? This is equal to, write it. Lekho. When mu is not equal to 1, so this is equal to infinite discontinuity at x is equal to a. So limit x tends to we shall write limit epsilon tending to 0 plus, it is a plus epsilon to b dx divided by x minus a whole to the power mu. This is equal to limit epsilon tending to 0 plus, this integration is x minus a to the power minus of mu plus 1 divided by this. This will be from a plus epsilon to b, that is equal to limit epsilon tending to 0 plus, if I put b, it is b minus a to the power 1 minus mu divided by 1 minus mu minus a x is equal to a plus epsilon put karo. So it is epsilon to the power 1 minus mu by this. Here we will get two limits. When mu is less than 1, when mu is less than 1, suppose mu is equal to 1 by 2, it is less than 1, then we are getting here, this is a constant part, there is no epsilon, so it is a constant part. I have no tension about this part. So this part will decide the characteristic of limit. So if mu is less than, suppose it is half, then we are getting here, it is epsilon to the power half. This will give you epsilon to the power half. So epsilon tending to 0 mane, this is 0 to the power half, that is 0. So this part will become, this total part will become 0. So we are getting this value. b minus a to the power 1 by mu by 1 minus mu. And when mu is greater than 1, mu is greater than 1 মানে power of epsilon will be negative. So epsilon wala term will be in denominator, and epsilon tending to 0 মানে denominator will become 0. That means total term will become undefined. So that means this will divergent. That means divergent or does not exist. Divergent. I clear, Babu, what I want to say? I clear?
Yes, sir.
Yes. So final conclusion lekho. Final conclusion is this: integration a to b dx by x minus a whole to the power mu converge when mu less than 1 and diverge when mu greater equal to 1. Diverge when mu greater equal to 1. Next lekho. Same result. This is your homework. You will do this. This is your homework. You will do this. Lekho. This is your homework. Integration a to b. Integration from a to b. Integration from a to b. Dx divided by b minus x to the power mu converge for mu less than 1 and diverge for mu greater equal to 1. Mu greater equal to 1. Same process, same result, same result. Here the improper integral has infinite discontinuity at x is equal to b. So you will just integrate from a to b minus epsilon. I bolo, have you done this? Have you done this type of problem in your college? Babu, have you done this type of problem?
So can you please repeat, sir? Here the infinite integral has?
Bolo na, at which point? Bolo?
So the last sentence that you just said.
So this a to at x equal to b, this is 0. So infinite discontinuity at x equal to 0.
Okay, sir.
I Sivan, have you done it in your college?
আচ্ছা জানি না স্যার কি কি করেছি ইন্টিগ্রেশন সময় ছিলাম আমার তো কিছু করায়ও নি
ইন্টিগ্রেশন তোমাদের করায়নি?
করিয়েছে কি করিয়েছে সেটা জানি
না স্যার, আমাদেরও করায়নি এরকম।
তোমাদের ইমপ্রপার ইন্টিগ্রাল করায়নি?
করিয়েছে কিন্তু এই ধরনের মিউ দিয়ে করায়নি কোনো।
তাহলে কি করেছি ইমপ্রপার ইন্টিগ্রাল থেকে?
মিউ টেস্টটা বেশি করে করিয়েছিল।
হ্যাঁ, মিউ টেস্টটা করতে হলে তো এগুলো লাগবে, না লাগলে মিউ টেস্ট করবে কি?
কিন্তু এরকম অঙ্ক আমি দেখতে পাচ্ছি না খাতায় করায়নি।
তাহলে এইগুলো না জানলে তুমি মিউ টেস্ট অ্যাপ্লাই করবে কি করে? হ্যাঁ, এগুলো তো লাগবে।
স্যার আমাদের ডাইরেক্ট মিউ টেস্টের স্টেটমেন্ট থেকে করিয়েছিলাম, আমাদের এইগুলো কিছু করায়নি।
আচ্ছা ঠিক আছে, লাগবে, ঠিক আছে লাগবে এগুলো, ঠিক আছে। লেখো। আচ্ছা 1 মিনিট বাবু, 1 সেকেন্ড হোল্ড করো, 1 সেকেন্ড হোল্ড করো। এখন ওর ইয়েটা নিয়ে নেবে, ওর দুটো কোশ্চেন নিয়ে নেবে, কালকের লাইফ সায়েন্সের কোশ্চেন আর বাংলার কোশ্চেনটা নিয়ে নেবে। আর একবার বলে আসবে যে ও আজকে ইংলিশ পরীক্ষাটা দেবে, কিন্তু মোট 4টে খাতা এনেছিলাম, তো 4টে খাতা এনেছিলাম, ওই 4টে পরীক্ষা দেবে, আজকে ইংলিশ পরীক্ষাটাও দিতে যাবে। হিস্ট্রি জিওগ্রাফিটাও পরীক্ষা দেবে, শুধু বলবে যে ইংলিশটাও আজকে দেবে। ওখানে বলেছিলাম তো লাইফ সায়েন্সটা দেবে না, কিন্তু বাড়ি থেকে দিয়ে দিয়েছে। ঠিক আছে, বলে দেবে, আর খাতাগুলো নিয়ে নেবে। নেক্সট হেডিং দাও, লেখো মিউ টেস্ট। হেডিং দাও মিউ টেস্ট। Mu test. Mu test. We shall apply mu test for both type of improper integral, type 1 and type 2. Both type of improper integral mu test. Mu test for type 1 improper integral. Mu test for type 1 improper integral. Mu test for type 1 improper integral. Statement লেখো, let fx be an integrable function. Let fx, small fx, be an integrable function when x greater equal to a, x greater equal to a, then integration a to infinity, এই দেখো x greater equal to a মানে it is integrable from a to infinity, that is why it is first type of improper integral. লেখো then integration a to infinity, then integration a to infinity fx dx converge absolutely if this converge absolutely if limit x tends to infinity, if limit x tends to infinity, x to the power mu into fx, x to the power mu into fx is equal to lambda, lambda মানে finite number, lambda and mu greater than 1, and mu greater than 1, and diverge अरे बाप रे, and diverge if limit x tends to, if limit x tends to infinity, x to the power mu into fx is equal to lambda, this lambda may not be not equal to 0, or this may be in plus minus infinity, this limit is either non-zero number or plus minus infinity, and mu less equal to 1, and mu less equal to 1. First I shall do some problems from here. দেখো, this is type 1 improper integral, so it is convergent when x to the power mu, it is convergent when limit x tends to infinity, x to the power mu into fx is equal to lambda, and this lambda is here may be 0 or finite number, but lambda is not plus minus infinity. But in case of divergent, this lambda is not 0, but it may be plus minus infinity, and value of mu will be less equal to 1. Then we shall say that it is divergent. We shall say that it is divergent. देखो क्वेश्चन लिखो তোমাদের কম্পারিজন টেস্ট করায়নি তাই না? কম্পারিজন টেস্ট করিয়েছে? কম্পারিজন টেস্ট করাবে না তাই করিয়েছে তোমাদের কম্পারিজন টেস্ট?
না স্যার আমরা শুধু মিউ টেস্ট করিয়েছি।
হ্যাঁ বলো, শুধু মিউ টেস্টই করিয়েছে, ওখান থেকেই কোশ্চেন দেয় তোমাদের, মিউ টেস্ট থেকেই কোশ্চেন দেয়। তাই লেখো test the convergence of the improper integrals. This number 1, first question is this. Number 1, integration 0 to infinity x square divided by root under x to the power 7 plus 1 this dx. The type 1 improper integral. So fx is equal to, here fx is equal to x square divided by root under x to the power 7 plus 1. Now here I shall multiply this fx by x to the power mu, and then we shall calculate limit. How will we choose the value of x to the power mu? We shall choose x to the power mu in such a way that power of x in numerator and in denominator will be same. I look at the board. Here in numerator it is x square, and in denominator the highest degree term is x to the power 7 by 2. So that means I have to make these two powers same. So we shall multiply this by x to the power 3 by 2. That is here x to the power mu. Then these two power will be same, and easily we can find limit. I clear what I want to say? We shall do it. Lekho. So limit x tends to infinity, x to the power 3 by 2 into fx. This is equal to limit x tends to infinity, x to the power 3 by 2 into x square divided by root under x to the power 7 plus 1. This is equal to limit x tends to infinity, and this add karo, it will be 7 by 2. So I can write it in this way. This. देखो, the highest degree term in denominator and numerator are same. So now we can easily calculate limit. So limit x tends to infinity. If I divide by x to the power 7, it is 1 by this. X tends to infinity mane this part is 0, so finally it is 1, which is finite number. I lekho which is finite number, and mu is equal to, here mu is equal to 3 by 2, that is greater than 1. Lekho. Therefore by mu test, mu greater than 1 and limit is finite. So what does it mean? Convergent, তাই না? Convergent. লেখো, therefore by mu test the given improper integral is convergent. Given improper integral is convergent. Any problem, Babu? Any problem in this question? Any problem in this question? Have you done in this way? In your college, have you done in this way?
Yes, sir.
Yes. Very good. Next, Lekho. Now, I shall give you 2 questions. Please do it. Lekho. Lekho. Number 2, second is this. Integration 0 to infinity. It is x to the power 3 by 2 divided by, it is b square into x square plus c square this dx. Lekho, here b and c are non-zero constant. Here b and c are non-zero constant. Non-zero constant. Lekho, what are you getting? So fx is equal to, write it, let fx is equal to x to the power 3 by 2 divided by b square x square plus c square. এই দেখো, here highest power in numerator is x to the power 3 by 2 and in denominator it is x square. So you have to multiply it by x to the power half, then power will become same. So lekho, limit x tends to infinity, x to the power half into fx is equal to, limit x tends to infinity, x to the power half mane this will become x square. It is b square x square plus c square. So this is limit x tends to infinity. Here if I divide by x square, 1 divided by this is b square, c square by x square, it is 0. So that means it is 1 by b square, which is finite number. Which is finite number. Therefore, look, which is finite number. Therefore, the finite number and mu is less than 1 and mu is equal to half. Mu is equal to half, it is less than 1. Therefore, by mu test, given improper integral is divergent. Given improper integral is divergent. Next lekho. Next lekho. This is integration from 1 to infinity. Integration from 1 to infinity. X minus 1 into root x divided by 1 plus x cube plus sin x this dx. This is also type 1 improper integral. লেখো fx is equal to, write it, let fx is equal to this, let fx is equal to this. Here in numerator highest power of x is x to the power 3 by 2, in denominator it is x cube, so you have to multiply by x to the power 3 by 2, x to the power 3 by 2. देखो limit x tends to infinity, limit x tends to infinity, x to the power 3 by 2 into fx is equal to limit x tends to infinity, it is x to the power 3 by 2 into x minus 1 into root x divided by 1 plus x cube plus sin x. So this is limit x tends to infinity. This will give you x square, this into this মানে x square, so multiply করো x cube minus x square divided by 1 plus x cube plus sin x. Now we shall divide by x cube in denominator and numerator, so this will give you limit x tends to infinity, it is 1 minus 1 by x cube মানে it is 1 by x cube plus 1 by x square plus 1 plus sin x by x cube. This is equal to, this is 0, it is 0, this is 0, and sin x is finite number. Sin x lies between minus 1 and 1. So this will become minus 1 and 1 divided by infinity মানে this is 0. So it is 1, which is finite number. I লেখো which is finite number, which is finite number, and mu is equal to 3 by 2. Mu is equal to 3 by 2, it is greater than 1. Therefore by mu test, given improper integral is convergent. By mu test, given improper integral is convergent. Next লেখো mu test for type 2 improper integrals. Mu test for type 2 improper integrals. A statement লেখো let fx be an integrable function. Let fx be an integrable function in the interval a plus epsilon to b, where 0 less than epsilon less than b minus a. এই দেখো, so this means actually the function will have infinite discontinuity at a. That is why they have integrated from a plus epsilon to b, and epsilon মানে this length, So obviously epsilon is greater than 0 and this total length is b minus a. So epsilon never exceed b minus a. This. Then integration from a to b. Then integration from a to b fx dx converge absolutely if limit x tends to a plus, x minus a whole to the power mu into fx is equal to lambda and mu is greater than 0, less than 1 and diverge if limit x tends to a plus x minus a whole to the power mu into fx is equal to lambda. This lambda is not equal to 0 but it may be plus minus infinity and mu greater equal to 1. Then we shall say that it is divergent. This is for type 2 improper integral. I question lekho. Number 1, first is this. Number 1, integration from 0 to 1 dx divided by 1 plus x into root x. Solution lekho. Let fx is equal to this. Fx is equal to 1 by it is root x into 1 plus x. I bolo to at which point it will have infinite discontinuity. Dekho at x equal to 0 this will have infinite discontinuity. Tai na? Lekho. Which has infinite discontinuity at x is equal to 0. So here infinite discontinuity at x equal to a, that is why we shall multiply by x minus a whole to the power mu. Here how can I choose what will be value of mu? How can I choose what will be value of x to the power mu? Our aim will be to eliminate the part which will give you infinite discontinuity. This part will give you infinite discontinuity at x equal to 0. So we shall try to remove this part. That is why we shall calculate, lekho, limit x tends to 0 plus, we shall multiply by x minus 0 to the power half into fx. So this is equal to limit x tends to 0 plus, this is actually root x, or 1 divided by root x into 1 plus x, this cancelled. So it is limit x tends to 0 plus 1 divided by 1 plus x, which is equal to 1, which is finite number, and mu is equal to, this is half, লেখো here mu is equal to half, which is greater than 0 less than 1. Mu is equal to half, that is greater than 0 less than 1. Therefore by mu test the given improper integral is convergent. Given improper integral is convergent. Number 2 is your homework. You will do this. Number 2, this is your homework. Integration from 0 to 1 dx divided by, it is x square plus x whole to the power 1/3. This is your homework. Next lecco. Number 3. Integration 0 to 1 dx divided by.
So I did not copy the previous question.
Acha, you will ask
The
your
homework
friend.
question.
Okay, you will ask your friend. Be fast, go. X to the power half this into 1 minus x to the power 1/3. What was the previous question? This is 0 to 1 dx divided by x square plus x whole to the power 1/3. This was the previous question.
Okay, sir.
Okay, देखो. So integration, this question we shall do. Integration from 0 to 1 dx divided by x to the power half into 1 minus x to the power 1/3. I follow at which point this has infinite discontinuity? Bolo, at which point it has infinite discontinuity? Both at 0 and at 1. Both at 0 and at 1. So we shall break this improper integral into two improper integrals. Lekho. Let fx is equal to 1 divided by, it is x to the power half 1 minus x to the power 1/3. Lekho. Let integration I is equal to integration from 0 to 1 fx dx. This is equal to, I shall take this as integration from 0 to half fx dx plus it will be half from 0 half to 1 fx dx. This is equal to I1 plus I2, where I1 is equal to lekho, where I1 is equal to integration from 0 to half this fx dx, where I1 is equal to integration from 0 to half fx dx. Lekho, here fx in I1, here fx has infinite discontinuity. Here fx has infinite discontinuity at x is equal to 0. And here for this part, here fx has infinite discontinuity at x equal to 0, and this part will be the responsible for this discontinuity. Lekho. So limit x tends to 0 plus, we shall multiply by x to the power half this into fx. So this will give you limit x tends to 0 plus x to the power half multiply karo, we will get 1 minus x to the power 1/3, which is equal to 1, which is equal to 1. Lekho. Therefore, I1 is convergent. Therefore, I1 is convergent. I1 is convergent. Now I2 check karo. I2 check karo. Lekho. Let I2 is equal to integration from half to 1, integration from half to 1 fx dx, where fx has infinite discontinuity at x is equal to 1. So we shall multiply this by, so देखो, for I2, this part is the responsible. So we shall multiply, so we shall take here limit x tends to 1 minus, because integration is from half to 1, it is half to 1, so x tends to this 1 minus, limit x tends to 1 minus 1 minus x to the power 1/3 this into fx is equal to limit x tends to 1 minus, if I multiply by 1 minus x to the power 1/3, we are getting x to the power this, that is 1. Therefore, I2 is convergent. Lekho. Therefore, I2 is convergent. Therefore, I2 is convergent. Lekho. Since I1 and I2 both are convergent, since I1 and I2 both are convergent, therefore I is convergent. Therefore I is convergent. I write a note here. Write a note here. Note lekho. Note lekho. If I1 is convergent and I2 is divergent, if I1 is convergent and I2 is divergent, then I will be divergent. That means if any one of the two integrals, if any one of the two integrals is divergent, then it is divergent. But if I1 and I2 both are divergent, if I1 and I2 both are divergent, then I may or may be convergent, may or may be convergent. So if both of two improper integrals are divergent, we cannot say anything. Okay, this is very important result. Next lekho. Number 4 is homework. You will do this. Number 4. This is your homework. You will do. Number 4. Integration a to b dx divided by x minus a this into root of b minus x. This is your homework. Next lekho number 5. Lekho. So that integration 0 to pi by 2 sine to the power mx divided by x to the power n this dx converge if n is less than m plus 1, if n is less than m plus 1. We shall show that it is convergent if n is less than m plus 1. This is type 2 improper integral. Lekho. Let fx is equal to this sine to the power mx divided by x to the power n, which has infinite discontinuity, at x is equal to 0, which has infinite discontinuity at x is equal to 0. So we shall multiply this by lekho limit x tends to 0 plus. Here we shall use this result we have done in class 11-12. This limit is 0. So I need here to get sin x by x solar term. That is why we shall multiply it by x to the power n minus m this into fx. Then this will give you limit x tends to 0 plus, it is x to the power n divided by x to the power m this into fx mane sin to the power mx divided by x to the power n. This will cancel. It is limit x tends to 0 plus, this is sin x by x whole to the power m, that is equal to 1. So it will converge. So this is mu here n minus m. So lekho here mu is equal to n minus m. The improper integral will converge. The improper integral will converge if n minus m is less than 1. That is if n is less than m plus 1. That is if n is less than m plus 1. Next lekho heading the gamma function. gamma function gamma function লেখো gamma function is denoted by definition লেখো gamma function is denoted by this gamma n where n is greater than 0. This is very important. Gamma function is denoted by gamma n and is defined by gamma n is equal to this integration from 0 to infinity e to the power minus x into x to the power n minus 1 dx. This is definition of gamma function. Some results লেখো gamma 1 is equal to 1, gamma half is equal to root pi. These are results. Gamma n plus 1 is equal to n into gamma n. That is we can write it in this way. Gamma n is equal to same thing. It is n minus 1 into gamma n minus 1. Next is gamma n will be equal. বলো
গামা n প্লাস ওয়ানটা একটু পড়ে দেবেন, ওটা কি গামা n আছে ডান দিকে?
হ্যাঁ গামা n, কারণ দেখা যাচ্ছে না, এটা এই দিকটা দেখা যাচ্ছে না,
মানে ঘোলা আসছিল তখন।
n into gamma n, ঠিক আছে লেখো gamma n is equal to, we shall write n minus 1 factorial when n is positive integer. Write it. Gamma n is equal to n minus 1 factorial when n is positive integer. Another important result is this: gamma m into gamma 1 minus m is equal to pi into cosec m pi. Pi into cosec m pi. Next লেখো beta function. Heading দাও beta function. লেখো it is denoted by capital BMN. Here m greater than 0, n greater than 0. Defined by beta mn. This and is defined by this. Definition is this: beta mn is equal to, it is integration from 0 to 1 x to the power m minus 1 minus x to the power n minus 1 dx. This is beta function definition. Some results: beta mn is equal to beta nm. Beta mn is equal to this is relation between gamma m into gamma n. gamma n divided by gamma m plus n. Beta mn has another value. It is 2 times integration from 0 to pi by 2 sine to the power 2m minus 1 cos to the power 2n minus 1 this theta d theta, this theta d theta. So these are values, these are definitions and results of gamma function and beta function. Have you done this in your college? Have you done beta function, gamma function? Yes, okay. Now just start this and next day we shall finish it. Just do very simple sums. Lekho. So what is this? Question is this: what is gamma 5 by 2? Gamma 5 by 2, I have written the formula. Gamma n mane it is n minus 1 into gamma n minus 1. So this is 3 by 2 into it is gamma 3 by 2. So gamma 3 by 2, that is equal to 3 by 2 into this. Again I can write it n minus 1 into gamma n minus 1. So that is 3 by 2 into half into it is gamma half. Gamma half mane value is root pi. So it is 3 by 4 into root pi. From next sum onward, I can directly use this. Just subtract 1. Just subtract 1. So for example, again, gamma 7 by 2, this will become, if I subtract 1, it will be 5 by 2. Then again subtract 1, it is 3 by 2. Again subtract 1, it is half. Then it will be gamma half. We shall use this result later. Next example is this. Gamma 5 is equal to, this is 5 is integer, so I shall write it 4 factorial. 4 factorial. Gamma 5 is 4 factorial. Lekho. What is this value? Beta 3 comma 4. Beta 3 comma 4. What is this value? This is gamma 3 gamma 4 divided by gamma 3 plus 4. So gamma 3 mane it is 2 factorial. Gamma 4 mane 3 factorial. Gamma 7 mane 6 factorial. So just you will find the value. Just you will calculate this value. This example, suppose this integration 0 to infinity e to the power minus x into x to the power 3 by 2 dx. What does it mean? So this is integration 0 to infinity e to the power minus x. You can write it as gamma 5, x to the power this dx. So this is from definition of gamma function. N is equal to 5 by 2. That is gamma 5 by 2. So this value is 3 by 2 into half into gamma half mane root pi. Gamma half mane root pi. Similarly, this is integration from 0 to 1 x to the power 3 by 2 into 1 minus x to the power suppose 5 by 2 this dx. This is beta function for After doing this sum, we shall finish class today. Next day, I shall complete beta function, gamma function, and multiple integral. That is tomorrow. Tomorrow also we have class from 10:30 to 12:30 or 1 till end of multiple integral. Tomorrow we shall do same class. So it is integration 0 to 1 x to the power, you can write 5 by 2 minus 1, and 1 minus x to the power you can write is 7 by 2 minus 1, this dx. So this is gamma 5 by 2, gamma 7 by 2. Beta 5 by 2, 7 by 2. That is, it is gamma 5 by 2. This into, you are getting gamma 5 by 2 into, this is gamma 7 by 2 divided by gamma 5 by 2 plus 7 by 2 minus 6. So this will give you gamma by 2 money, you can calculate now 3 by 2 into half into gamma half money root by this into 7 by 2 money, it is 5 by 2, 3 by 2 half into root by divided by 5 factorial. Just you will simplify this, you will get the result. You will get the result. I just keep till here. Next day I shall do difficult problems from beta function, gamma function, and then we shall end multiple integral. Next class we shall finish improper integral calculus all apart. Okay. So keep till here. Thank you very much, Babu. Thank you. Tomorrow also we have class from 10:30. Okay. Now we can leave.